impulse is equal to change in momentum, which is equal to Pf minus Pi, which is also equal to mvf minus mvi, or m times vf minus vi, or m delta v. Yes, the change in velocity times mass. So we need to make a careful form here, a reasonable one rather. And now next up we have the elastic collision. Elastic collision. So the proposition once again is that momentum initial is equal to momentum final. Okay, elastic collision and momentum final is equal to momentum initial. Okay, this is basically two masses interacting, mass 1 and mass 2, and with v1 and v2 as initial velocities, and then we have the m1 and m2 with u1 and u2 as initial velocities, and excuse me, m1 with initial velocity u1 and m2 with initial velocity u2. And then we have a situation where we have this m1 v1 and then m2 v2, the final velocities after collision. Yes, so this is where the collision basically takes place, if you know what I mean. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, so this is the equation 1. Equation 1. And after m1 u1 and then v1 after collision, m2 u2 and then v2 after collision. Okay, equation 1, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. We rearrange m1 u1 minus m1 v1 is equal to m2 u2 minus m2 v2 minus m2 u2, m2 v2 minus m2 u2. Okay, m1 u1 minus v1 is equal to m2 v2 minus u2. So this is the second form, the second equation here. And also kinetic energies are equal. Final is equal to kinetic energy initial in systems. So from this proposition we can develop an assertion 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. We rearrange 1 by 2 m1 u1 square minus excuse me, m by m 1 by 2 m 1 u1 square minus 1 by 2 m2 1 by 2 m1 v1 square is equal to 1 by 2 m2 v2 square minus 1 by 2 m2 u2 square. Okay, so now we take the factors out. 1 by 2 cancels out, so m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square. So this is very much 3 now. Okay, so now we divide 3 by 2. Okay, equation 3 divided by equation 2. So what we get is m1 u1 square m1 u1 minus v1 into u1 plus v1 divided by m1 u1 minus v1. Okay, and m2 v2 minus u2 into v2 plus u2 by m2 v2 minus u2. m1 and m1 cancel out, m2 and m2 cancel out, u1 minus v1 cancels out with u1 minus v1 below, and also v2 minus u2 cancels out with v2 minus u2 above and below. What we're left with is u1 plus v1 is equal to v2 plus u2. Okay, which means that u1 minus u2 is equal to v2 minus v1 if you rearrange. So this becomes equation 4. The difference in initial velocity is equal to difference in final velocity. Okay, this form can be used further analysis. And if we are to look into the intricacies of projectile motion, we are poised to do that because we have the foundations laid, and we will try to do that as well. Projectile, and we are looking into the approximation of the velocity and the